Hello again, my learners. How are you? How are you doing? It's Murad Sultan Zwidi. So now we'll be on the fourth week, grade 10, fourth week, 28. Okay, 28 and 29th of March 2021, semester 2. Topic curved graph. As we'll see the hyperbola. Okay, then also we'll see what the graph of hyperbola, that is written in terms of y equal k or a over x. Okay, the a is real numbers and exponential function exponential function. Okay, function that is written on the term of a to the power x. Okay, so let's focus on this one. So okay, we told a over x. Okay, now we start. The graph of a reciprocal function have similar shapes. They are discontinuous and have two parts. They don't cross or touch the x-axis or the y-axis. Means this curve, when k is positive, so the curve of this equation, it's called hyperbola, will located at the first quadrant and the third quadrant. Okay, and this is, it's called the lines of symmetry. Here we have a lines of symmetry y equal minus x, and here also we have a lines of symmetry y equal x. We'll see this after. Then we told that, but get near and near to them, get near and near to x-axis and near to y-axis, but never touch them. Okay, so we say that the axes are asymptote to the graph. As the curve, let's say get near and near to the y-axis and x-axis and never touches, means that the y-axis and the x-axis are called asymptote. Okay, then this is when k is positive, when k is negative. So the curve of this hyperbola of this equation y equal k over x, k here is negative, is a constant, it's a, it's b, c is a real number, can be negative, can be positive, and so on. But here in this case number 2 is negative. For example, minus 2 divided by x. So this one, this is the curve of this equation. It's called hyperbola. So this hyperbola, you can see the curve goes or gets near and near to the y-axis and near to the x-axis here in the second quadrant. In the fourth quadrant also the curve goes near and near to the x-axis and near to the y-axis, but never touches. That's why the lines, the axis, the x-axis and the y-axis here are called asymptote to the graph. And here we have, let's say y equal x is the first line of symmetry, and here y equal minus x is the second line of symmetry. Okay, now an example. We'll try to let's say we'll try to draw or complete this table of values for y when x equal negative 4. So it will be negative 1 over 4. When x equal negative 3, it will be negative 1 over 3. Just substitute in x negative 3. When x equal negative 2, it will be 1 divided by negative 2. Then when x equal negative 1, it will be what? Okay, it will be here. Okay, okay, so here you can see that when x we told equal negative 1, x equal negative 1, so 1 divided by negative 1 gives negative 1. When x equal negative 2, 1 divided by negative 2, it will be negative 2. When x equal negative 1 over 4, 1 divided by negative 1 over 4, it will be negative 4. when x equal 1 over 4, 1 over x, it will be 4. The inverse of 1 over 4 is 4. When x equal 1 over 2, the inverse of 1 over 2 is 2, and so on. Okay, clear? Now we just plot this point, my learners. We will try to plot this point, of course. So here, when x equal negative 4, okay, y equal negative 1 over 4. This is negative 4, this is negative 1 over 4. Then negative 3, negative 1 over 3. Then negative 2, negative 1 over 2. Negative 1, negative 1. And then negative 1 over 2, it will be negative 2, and so on. So we draw the first graph of the hyperbola y equal 1 over x in the third quadrant. Why? Because 1 is positive. Here the number 1 is positive. So just draw the first one in the third quadrant and draw it symmetrical. Okay, reflect this by the lines of symmetry y equal minus x. Okay, and vice versa. So make a table of values like that and try to find the value of y. Then plot the points and join the two parts with smooth curves. For example, this part, negative 4, negative 1 over 4. Okay, the second part, we will try to use a smooth curve. Then, now we draw, let's say, the first one. The equation of the lines of symmetry of the graph are y equal x and y equal minus x. You see, this is y equal x. Okay, this part is symmetrical to this. Okay, this is the equation y equal 1 over x. Also, this part, this one, from this to that is symmetrical to this to that. Okay, agrees to the y, the lines of symmetry y equal x. And also for the second one, when y equal minus x, so this one, it will be symmetrical to that, and this one, it will be symmetrical to that, and so on. This is the curve of the equation y equal 1 over x, which is called a hyperbola. Now keywords, we move to exponential function. An exponential function, my learners, is a function that can be described by let's say an expression of the form y equal ax, a to the power x. X here is index or power, where a is positive and a can be equal to 0. We told okay. So as with other function, you can also use order of pairs to graph exponential function. And here graph an exponential function with a is greater than 1. So y equal 4 over x, 4 to the power x. Take the y-intercept. Y-intercept means x equals 0. It will be this one. It will be 1. When x equal minus 2, it will be 4 to the power minus 2. It will be 1 over 16. Okay, when x equal minus 2, y equal minus 1 over 16. This is the y-axis, and this is the x-axis. Then when x equals 0, for example, it will be 1. X equals 0, this is, it will be 1. Means that the curve of the exponential function passes through the point 0, 1 always. Okay, when x equal 1, it will be 4. X equal 1, it will be 4. When x equal 2, it will be 8, and so on. Okay, so here then in order to draw the graph of this, just plot each ordered pair of numbers on the coordinate plane. You will get your curve, and try to use a smooth curve like that, and you be certain that the curve should pass through the point 0, 1, which is called the y-intercept. Okay, this one, my learners, is called the y-intercept. 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 Intercept of coordinates, of course, is the point A of coordinates 0, 1. That's why the exponential function passes through this point. Clear? Okay, I mean this one, this point. Okay, now we move to the second part. We told that the graph, let's say, a function of the form y equal ax, a to the power x, where a is positive, greater than 1, all have the same shapes. Okay, this is symmetrical, vice versa, the vis-a-vis the y-axis. Okay, you can see this before. This is like that, from left to right is the curve. The curve is sloping upwards from left to right, but here the curve will, let's say, going or going, let's say, upwards from right to left, but both equation should pass through the same point 0 1, which is the y-intercept. This is 0 1, the y-intercept. Now just substitute. Okay, be careful with this kind of questions. You already did in the consolidation task, but I will repeat this for you. 1 over 2 to the power x, in fact, is 2 to the power x to the power 1 over 2. It will be what? It will be Mallerner's, I'll move there, equation. What is equation? Symbols, equation. Okay, we told, no, not this, Mr. Murad, concentrate please, Mr. Murad. Okay, I will erase this one and this one. Okay, so we told 1 over 2 is 2 to the power minus x. Okay, the same, there is no difference between writing 2 to the power minus x or 1 over 2 to the power x. It's the same. Okay, so this is y equal, your equation, y is equal. Okay, you can see that. Okay, a is positive. Okay, so here the y-intercept Mallerner's is that when x equal 0. Okay, 2 to the power negative 0 is 2 to the power 0 is 1. Okay, so this the curve. Then just substitute in this equation. Negative 3, it will be negative 2 to the power negative 3, it will be 8. Then when x equal negative 2, just here put negative 2. Negative is positive, so it will be positive. It will be 4. When x equal negative 1, make here negative 1. Okay, negative 1, it will be 1. 2 to the power 1 is 1, and so on. Okay, then here we just plot the points 0 1 over 2 and so on, and draw the graph. Okay, Akin, please, I'm recording my daughter. So now use the graph to determine the approximate value of 1 over 2 to the power negative 2. Means x should be equal to negative 2.5. Okay, negative 2 to the power negative 2.5. Okay, and you will use your calculator or you will use the graph. When x equal negative 2.5, this is the y-axis, x-axis, this is negative 1, negative 2, approximately here this point. So draw a line like that, and you will find in this region you will find the value of y when x equal negative 2.5. The value of y is about 5 over 2 when x equal negative 2.5. Use your calculator to confirm that value. Okay, the next example here we saw another example of exponential function. 2 to the power x is the same here. So just when x equals 0, it will be y equal 2 to the power 0 is 1. Substitute x equals 0 in the line into y equal 2 to the power x and work its value. When x equal 1, just put here x equal 1. Okay, just a moment, I will need this one, I need this one, yes. Okay, copy, I'll come here. So look here, my learners, when x equal what? This is x. Okay, should be equal to what? When x equals 0, x equal 0, just put here, instead of writing x, make 0. Okay, 2 to the power 0 is equal to 1. Clear? And this one, it's clear, we done it. So the second one, this one is here, 1x of course. Okay, then when x, let's say, is equal to okay, okay, when x equal to that, this is the first. Okay, I will erase this. So when x, we told x equals 0, y equal, then I will continue. Okay, this is the knowledge. You can use your mind also to calculate it. Okay, okay. Now when x equal 1, so 2 to the power 1 is what? 2 to the power 1 is 1, is 2, sorry, is 2. Now when x equal 2, 2 to the power y equal 2 to the power 2 is 4. Clear? When x equal 3, or here minus, okay, 3, so y to the power 3 is 8. Okay, it will be 9, it will be 8, it will be 8. Now when x equal minus 1, okay, so 2 to the power minus 1, it will be 0.5, 0.5. Then now when x equal minus 2, so y to the power minus 2, it will be 1 over 4, it will be 1 over 4, also equal 0.25, and so on. Okay, then, and when x equal negative 3, it will be 0.25. I will just erase the last one. And here you can use this formula, use a table, result a to the power negative a, it will be a 1 over a to the power, and to work out the value of a negative value of x, or to write in an index notation, an index expression as where the index is positive. Okay. Now we just plot the points. Here we construct, or we made the table of value. Then we will draw the graph of this table of value. Okay, we will obtain like that. This is the graph of y equal 2 to the power x, that passes through the point 0, 1. Okay, and the x equal 2.6, so y should be equal to 6. Okay, this is when x equal approximately 2.5, it will be 6. Okay, thank you for listening, and see you inshallah next time. Thank you.